The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Welcome to the January 2019 edition of We Speak Linux. This is a broadcast that is dedicated to teaching Windows admins and developers Linux through presentations, blog posts, and peer support. Our goal is to grow a community of Windows administrators and developers who are interested in and able to transition to Linux as needed. So today, Andrew Mallett is going to talk to us about open source virtualization. His Twitter handle, which I absolutely adore, is The Urban Penguin. Andrew is also a Pluralsight author, and I'm looking forward to this presentation. If you want to join us, you can chat in the chat window here or join us on Slack for live chat in the webinar_chat channel. If you are not a member of our Slack channel, join us at wespeaklinux.com/join-slack. You can also hit us up on Twitter or YouTube, where we're going to post this recording later on. So with that, I am going to change over to Andrew as the presenter and allow him to take it away from here.
Hello and welcome. Thank you very much for inviting me. And I suppose to most of you, it's a good morning. For me, I'm based in the UK, so it's a little after 5 in the afternoon. And we're going to spend a little bit of time, as you can see, hopefully from my slide, open source virtualization. We're going to be taking a look as we run through this at a Linux KVM host. So KVM, you might know that, you might have heard of that. KVM is the de facto virtualization within things like AWS. They moved from Xen through to KVM just about 18 months ago. And also if you're building your own OpenStack cloud, KVM is going to be the default virtualization engine. So we'll be taking a look at KVM by itself rather than with all of the bells and whistles. And it's really designed around setting up a separate server without any graphical environment. Now, we don't want to get all text console on you and say the only way to go is text. But if we're looking at a virtualization host, there's no real need for us to have any graphical tools on that. The graphical tools really going to come from our desktop. And I'm using as my desktop OS X. Now on OS X, it doesn't come with an X server, but there's a free X server that you can download. And that means that I can run any of the graphical applications that I need on my virtualization host without taking valuable resources from my virtualization host. So in this way, we can get a virtualization environment up and running on a separate machine, not having to worry about your desktop. So we don't have to be too concerned if you need to reboot your desktop, if you're running some development on it over a period of time. You don't have to be concerned about keeping that desktop up and running for the 2 weeks or whatever whilst you're running your test process. Just run it on a separate host. We'll be looking at how we can create VMs, and we can do that from the graphical environment. As I say, using then the X server, I can then go through and run any of my graphical tools. Of course, if you didn't have that available to you, there's nothing really stopping you running a graphical environment on your virtualization host. But it's just one of those things that we do tend to like to separate the client side of things from the server side of things, so that we're not taking resources away from our virtual machines. We'll also be looking at something called nested virtual machines, having a virtual machine within a virtual machine. We're going to be starting off looking at my actual virtualization host, but then as we start working our way through it, we want to see how we can set up KVM. So I'll be setting up a virtual machine that could host virtual machines. Now, on the face of it, it's starting to get a little bit ridiculous. Surely a virtualization host is what we want. We don't need a virtualization host to host other virtualization hosts. Well, maybe you do. Maybe you want to start practicing a little bit more with KVM, but you don't want to do that on a live machine. Maybe you want to be installing OpenStack, but you don't have a separate machine to be able to do that. Well, as long as you've got enough RAM available, there's nothing really stopping you. But you'll see there's a couple of things that we need to set both on the host machine and on our virtual machine that we want to become a nested virtual machine. We'll be looking at cloud images, and the great thing about cloud images, they're not only available for KVM, but the manufacturer, the distribution vendor, produces the images for me, so I don't have to go through and worry about installing the operating system. Another really cool thing that we can do with KVM is to have resolvable host names. So if I start up a virtual machine, I don't particularly want to log into the virtual machine just to find out its IP address. It would be nice if I could connect directly to that virtual machine, and we can set up name resolution for our virtual machines. Now, when we look at KVM ourselves, KVM is not the actual hypervisor. A lot of people say, oh yeah, I'm using a KVM hypervisor. Well, KVM's not the hypervisor, it's QEMU that is the hypervisor. KVM itself is an accelerator, so it speeds up your virtual machines. Virtual machines themselves, when we think about it, they don't need to be really bothered with the hardware, because the hardware is attached to the host machine. And surely if the hardware is attached to the host machine, the host can worry about managing all of the hardware. So as an accelerator, KVM then can allow the virtual machine to skip any of those unnecessary tasks that are going to be looked after by the owner of the hardware itself, the virtualization host. Now, originally, this goes back to being a Windows product. It was designed by RV Kiviti for virtual PC as an accelerator for virtual PC. Back in the days, I don't know if anybody goes back as far as virtual PC, but it was then ported through to Linux and has become part of the Linux kernel. And its name then changed from the Kiviti virtual machine, named after RV Kiviti, the developer, into the kernel virtual machine. So it's pretty much going to be available as a module on any recent Linux system. But we've got to make sure that the hardware is set up and supported for KVM. And we can go out and look for flags. And this is what a lot of Linux people or Linux administrators are used to do, is checking for flags. So we could do that. And we've got to then check for different flags, depending if it's Intel or whether it's AMD. So that's something I don't particularly like. I don't really care so long as it supports KVM. So this is a traditional way of doing it, but to be honest, the easiest way is just go look for a file. If the file /dev/kvm exists, then you do have KVM support. Full stop, the end. We don't need to check anything else. So the very simplest way is to go through and check for the dev KVM file. Now, of course, we can get lost for ages in going through looking at slides. So say I've got my KVM host already set up and running. If I move out to the command line, this is then connected to the KVM host. If I just go through and exit out, we're back now on my Mac system. And when I connect in to the host machine, I'm using SSH minus uppercase Y. This is just so I can have X redirection through to my OS X client here. So if I want to run the graphical environments. So the KVM host is just a separate host running in my office here. So I can then go through and connect in. I'm just going to use Control and L, that clears your screen. So that's like the CLS command. With this then up and running, if I go through and run grep, If we want to do it the old school way, then we're going to use grep -e for an enhanced regular expression, because we need to look for one or other of our items. So we set up our group, and we're going to look for our VMX. So VMX is used if it's an Intel platform. If it's an AMD platform, then we need to go through and look for SVM, close off the parentheses, close off my quotes for my regular expression, and then we can go through and look in the proc file system. So this is very much like your Windows registry that's got the state of the current running machine, and then look at CPU info. So we can see there the coloring will show where it's found the flags. So I've got 4 processors here, and we've colored in VMX. So it looks like I should have support. But yeah, that was rather a long-winded way of doing it. If I just go through and use ls, the dir command if you like, and /dev and kvm, we can see that that file exists. And as I say, if that file exists, then we have got KVM support. So we're good to go from the point of view of whether or not we support KVM. And as I say, this machine is already running the KVM acceleration for QEMU, so pretty much I knew that anyway. But if you're checking your own systems, it's good to be able to find ways that we can find support. As we then continue, we can go through and look at downloading cloud images. So pretty much the first thing that we want to be doing is, once we've got it up and running, is to get an image that we can use. So they're available from most distributions. They can be customizable, and we'll look at that later during their first boot. And then we've got some downloads here. Again, I'm just downloading from the command line, so wget, and we can go through and download an Ubuntu image. I think I've got the URL here for a CentOS image. But again, if we just go through and grab this, let's just jump out and copy this across. Just give me a second, please. So this is then bringing the image down. You can see that it's coming down relatively quickly, but obviously the speed is going to be very much dependent. You can see I already had the image, so the image there has got just the .1 at the end. But if we want to then go through and start looking at this image, let's again go through, clear the screen, and then we can go through and run QEMU, and then disk. We should have that here somewhere. QEMU image, that's it. So we can go through then and use the QEMU image size. If I use then info and go through, look at then the Bionic, and we'll say it was the .1 file, so the copy. If we look, the actual disk size is 324 meg, so quite small. So we're probably used to this where we have sparse files. It's virtual size, so it can grow to 2.2 gig. Now that's going to be okay, but if you want to start storing lots of stuff on that, doesn't matter what you want to use it for, that's the complete disk that's got to house then the operating system and any data. So the reality is that is probably quite small. So if we just up arrow key, go through and change this to resize, we're going to resize our disk. But in doing so, we're only going to change its virtual size, how much it can grow to. If we go through and say set it to 40 gig, the great thing is that we're not going to take up any more space than the 324 meg that we're using. We can see the file format is QCal2, so that's really our QEMU copy on write. So until we actually write to that disk, we're not going to be using any more space. So if I go back and look at the info, we can see that it's exactly the same size. But now I can use this disk to initiate my virtual machines, and I leave the master image. This image here stays where it is. It stays in my home directory, but then I make a copy of it. The idea of making a copy of it is then that I don't touch this. All I've done here is set the 40 gig size, and that's about the only change that I'm going to do to it. Anything else is going to be customized on a per virtual machine basis. So if I want to look at setting up a virtual machine now, I've got my operating system that's come down. We want to now go through and copy the operating system disk across. Now, I could just use the CP command, the copy command. However, I'm going to use QEMU image again, because when we go through and look at it, I'm going to use sudo. So this is a bit like the run as. I want supervisory rights now because I'm copying it into a restricted directory. And we can then run the QEMU image command and then convert. Now, technically, I'm not converting it. It was already in QCal2 format. But as long as I get used to doing it in this way, it will copy for me if it doesn't need to convert. But if it also needs to convert from another cloud format through to QCal2, at least I know the one command is going to work for me, irrelevant of the original format. So we can then go through and use the Bionic and say it doesn't really matter whether now I use the image.1 or just the image, the original file, because they're both the same now. The other one would have just had its size modified. And I want to copy it across to the disk store. So my virtual machines have disk stores where they expect to find disks. So we're going to put it in the default location of var lib and then libvirt. And then we can go into the images subfolder and we can then call it, let's say, VM1. Normally, I call them after the virtual machine they're going to be assigned to. Of course, the nice thing is then when I'm tidying up virtual machines, if I've deleted a virtual machine called VM1, but I've still got disk less for VM1, then I can be pretty much certain which disks belongs to which virtual machines. So that's added the virtual disk file in. And as I say, we use the sudo command just to make sure that we've got the correct permissions. Now, chances are as well, we're going to need to customize the virtual machine. And there's a program that most cloud images have called Cloud Init. On the first boot of this disk, it's going to run Cloud Init and look for any customizations. Most often, we're going to be looking at customizing by adding SSH keys for authentication or by setting user passwords. So we're going to look at how we can set this up. First of all, we need a text file. So if I go through and look, I'm keeping everything in my home directory, and I'll just call it cloud.txt. It must start with the #cloud-config. So that tells it what type of configuration it's looking at, and also then designates the target file that it must be put into when we create the ISO file. We've got a very easy tool, though, to create the ISO file. Now, I've set the password, but I'm not specifying the user account. So it's the first user account, and this is then going to be the user Ubuntu if it's an Ubuntu-based system. If it was a CentOS-based system, it would be CentOS as the first user. I'm just making sure that the password doesn't expire. We're making sure that we can log in with passwords through SSH, and we'll probably go through and call this one VM1. So once we've got that saved, We need to now convert this through to an ISO file. So we have to make sure we've got an extra package. I'll go through all of the packages that we need to install later, but we need cloud image utils. It's available on your Ubuntu platform, but this then becomes a really easy way of creating the ISO file. So again, I use sudo because we copy it across to the correct location, and then it's cloud and local DS. So local DS is really just the data store that it's creating. We want to go through and create it in that same directory, so var lib and then libvirt. Don't worry about the double forward slash, it will just ignore any extra forward slash. I just must have been a little bit flaky on my keyboard. And then images, and we'll call it vm1.iso. And then we need to create it from the cloud.txt file. Now say the ISO then will have the correct format, the file name will be correct based around that first line being cloud config. So this becomes a really easy way of creating the ISO file. So we just need to make sure that we connect to our virtual machine the two disks. Now I can do this from the command line. I can also do it through the graphical tools. If we want to look at the graphical tools, because we haven't seen too much of this, and I don't want to make you think that everything has to be on the command line. There's advantages in the command line, there's advantages, of course, within the GUI. So if I start up Virt Manager, don't worry about any of the errors that we see here, but this then just fires up that application, but in my local X server. So this means that I can run the graphical applications without running the graphical environment on my virtualization host. I can then obviously go through to a new virtual machine, and we want to import existing disks. We're not really doing an install. We can go down and see what sort of architecture we want to use, but we're going to be sticking with x86. But you can see within the QEMU quick emulator, the hypervisor, there's lots of things we could potentially emulate, but we'll stick with the standard x86 here, and then we can browse through, and we can see we're looking in that directory, var lib, libvirt, and images. And if we go through, take a look, we want to connect then the, so it shows me with the virtual size, a 40 gig size. Now that's the only disk I can put in at this moment, but we'll see later I can add in, and we're using then Linux, and I'm setting, it's actually 1804, but the latest template they have is 1710, so that will do. Then go forward. I can set the amount of RAM that I want. So we can call it, let's say 4196, roughly 4 gig, the amount of CPUs I want. We can set up its name. So again, I might call this just VM1. So this is a virtual machine name. We can look at the network. So it's connecting to the network default at the moment, and that gets NAT access to the rest of the world. But I want to customize and then finish. Then we go down to our storage, we can see that we've got the one virtual disk in here. But if I go through to add hardware, we can then again browse through, choose that it's a CD-ROM, and then this time we can obviously put in the ISO file. We can then go through and finish. And now, even though it says begin installation, that's just the button. We're obviously going to fire up the virtual machine. So as it goes through, it's going to be booting up first of all from the ISO, but it should then switch across to the disk. So this is our disk image that we downloaded. And say that just has then Ubuntu 18.04 installed. So all we're doing now is booting up from the pre-installed disk. But during the boot up phase, we are then going to be customizing it. So you can see then that we've got the VM1 login, so the host name is correct, and we'll see how well the environment is working. We can log in as the Ubuntu user. And remember, I set the password, so I just set a simple password here, but then I can go in and log on to the system. So we can see that by utilizing our cloud image, just downloading the pre-built image, and then looking at ways that we can customize it. First of all, we looked at just extending the size of the disk. Again, if I just clear the screen on this and look at df-h to look at our free space, we can then go through and see just on the dev VDA1, my virtual disk there, we've got 38 gig of available space. So that's our first customization. We then went and created our cloud config file. Our cloud config file then set the password and our host name. Now with that then done, we can exit. That's just going to log me out. I can then just go through and close this off. We can leave the virtual machine running, but then if I go through from the command line, obviously it's all up and running now, but a couple of ways I can connect from the command line. I can use virsh console and then the VM name. Now we can see there the escape character is control and right square brackets. If I just hit enter, it will take me to the login screen, but then we can log in then as the Ubuntu user with the password as we saw before. Again, same keys work, the same control and L, and then I can exit to log out. And I get the login screen, but this is where the escape keys came in. So control and right square bracket will then just take me back to my normal prompt. So we can use the graphical environment to get our virtual machine up and running. But if we wanted to, we could use the command line. And this is where the command line probably doesn't look too hot. If I go through and just take a look at a little script that I've created. So we've got the command virt install. Again, I'm running that with sudo to make sure that I've got full rights. I'm passing a couple of variables through. So the first one we use for the name. So as I run the script, I specify, first of all, the virtual machine name, and second of all, the $2 variable is being used for the memory. And we specify that in megabytes. So if I want 4 gig, it's going to be roughly 4,000 or whatever I put in there. Then we go through to the 2 disk files, so both the image and the ISO file that we want to use. Again, using the virtual machine name, $1 as a variable there, and then just setting it up as Linux, Ubuntu 16.04 as its template type. Make sure that we're using KVM, so that's going to allow me to use acceleration. So when I start looking at the disk device, when we looked at disk free, seeing it as VDA, a virtual disk, rather than the normal SCSI disk of SD. And this is then going to give me that improvement in speed, the acceleration. Don't need to worry about setting up graphics and then going through and making sure that I connect to the default network. And then importing rather than an install. And again, we can look at pretty much the way this would work. So let's just set up some disk files again. So if I just go back, we can then say create, say, a VM2 image. So we're just copying across that same file. Let's go through and vim and take a look at the cloud.txt. Remember, this was the text file that we use for cloud init and create the ISO file from. And then we can call this VM2. and then go through and run our cloud local DS. And this, of course, needs to go across to the VM2 ISO. Now I can just go through then and run the install. We'll give the name of VM2. So that's the first variable that we use. With that done, then we can go through and set up, let's say 4196 or whatever that value is. So setting up roughly 4 gig of RAM. And this then goes through. It connects to the console by default. So that's again where we're seeing the escape character. And it will again wait a little while as it negotiates to go to the hard drive and then starts the install. So you can see the command line can be fairly ugly when we look at how many switches there are there, but then we can make it very usable by using a script rather than trying to remember all of the switches at the outset. So we can now go in and log in. And again, this is pretty much going to be the same. So if we look at df-h here, we again see this is then the 38 gig because it's a copy of that same disk. Exiting out, and then of course we can just use our control and square bracket to return back to our host machine. Now, if we do want to connect via standard clients, we can also use SSH and then Ubuntu, so the user account at, and then the virtual machine name. So if I go through and take a look at this, that should pick that up. My VM1 is still running. Yeah, I know what it is. Let me just go through. What it looks at is, when I'm looking at VM1, is the name that's been assigned through DHCP. But when my machine got its host name, it was during that first boot, so its name hadn't been set. So if I just go back in to my first console here, and we'll just reboot it, and then it will pick up its, it will reissue its name. So if I go through and log in as Ubuntu, and then password 1, and then go through and just do a sudo and reboot. And then again, I'll just leave the console, give that a little time to reboot. Whilst we're here, if I look at the virsh command, I can run virsh and then any options that I want. But if I hit virsh and enter, we get interactive. So I can do things like just list. So that lists the virtual machines that are currently running. Or I want to see all of the virtual machines, minus all. We can add in the minus all, so we can see if they've got an ID, they are running. If they don't have an ID, then they're not running. If I want to look at the network to have a look at what we were looking at, if I go through and look at the DHCP leases for the network they were connected to, so default, we can see that the two machines that we've got running there, we've got the host name of VM1 and the host name of Ubuntu. Well, again, I've rebooted the VM1 machine, but I haven't rebooted the VM2 machine. So the original host name will be Ubuntu. The machine boots, presents that host name to the DHCP server, but during that boot process, it's also changing its name via cloud init. That's why we just want it to regain its DHCP lease, or just reboot it is a simple mechanism. With that done, if I just exit out, and now I should be able to SSH as the Ubuntu user. So the Ubuntu is the user, but the host name now is VM1. We can accept the public key, and then add in the password. So ongoing, I want to be using SSH to connect through to my virtual machines because it's just a more standard way of doing it. When I'm managing my virtual machines, I can either use the graphical tools or the command line. We're just going to drop back for a moment back into our slides. So if we wanted to look at that customization, this is the cloud config file that we saw from the command line using the cloud and local ds command. And I think these slides will be made available to you at some stage. We can look at starting the VM either through the GUI or then the script that we saw. We can connect to the virtual machines. We can use things like virtualist to see them or list all to see all, including those powered off. We can use our Virtual console, but we have to have a serial console defined to be able to connect onto the console. So often is in cloud machines. If not, then we've got to use SSH. If we want to look at the IP addresses, then we can use VirtNet DHCP leases and default for our network to see the IP address. But so I've also set up the hostname resolution. So with this, we need to make sure that we've got the libnss and libvirt package installed. That's going to give me the libraries that I need. And then we edit our name service switch configuration, the NSS switch configuration. And for our host name, we look in our local files. So that's going to be our host file. We then look for libvirt. So that's going to be the name from DHCP. We can also include libvirt_guest. So we should be able to resolve guest names. Finally, we look at DNS. Obviously, I can put these in different orders if we prefer to check other resolutions first. So again, sometimes people switch DNS before files, just for the fact that we are getting names from a trusted DNS server rather than perhaps somebody who's had an attack on their local host file and had weird host names and the IP addresses being added in. So again, all of this had been done on my system. So that's where then after the reboot, I could connect in to the guest just using the name of the virtual machine. The nested KVM support. So if I want to host virtual machines in one of my virtual machines, and this was talked at the beginning, we might want to do this because we want to test KVM further, but we don't want to work on our actual host machine. Or we might want to be trying OpenStack. So we want to get OpenStack up and running. Even though OpenStack can run without KVM, KVM is our accelerator, our virtual machines are going to run more slowly if we don't have KVM support. So with our virtual machines, if we want to connect to them through the graphical tool Virt Manager, we can set up the CPU to copy the host CPU configuration, or from the command line, we can go through and use virsh and edit and set the CPU mode to be the host model. We then should be up and running as far as our virtual machine. We only need to do this on the one virtual machine that we need to nest in. On the host system, and this will already be set up on mine, but we need to allow nested virtual machines. So we go through as root, creating a file etc modprobe.d. So this is really where our modules load from. And we specify, it can be called anything, but it would make sense calling it kvm.conf. And then we go through and put the option. So when the module loads kvm_intel, it loads with the option nested equals 1. Now, obviously, if you were using a MD-based system, you wouldn't use KVM_Intel, you would use KVM_AMD. So let's pop back out to our command line. If I go through and if I look for the file /dev/KVM, remember I was saying this is a great way to see if we've got KVM support. And well, we don't have KVM support, or it doesn't appear we have KVM support. So let's just go through and do a sudo and power off at the moment. So we've powered off, and that will have automatically ended my SSH session. And if we go back into our Virt Manager, and then we can see the virtual machine shut off now. And if we then open and go to the info, check the CPU, and just tick copy host CPU configuration. So I'm just moving across, instead of the graphical console, just moving across to look at the hardware details, moving down to the CPUs, and then just ticking copy host CPU configuration. If I then go through and apply that, that writes back to the XML file that defines the virtual machine. So now if I go through and power on my virtual machine, don't worry about it, it seems to change back at this stage. That's just the way the graphical environment is showing. You say, well, okay, we've got then Sandy Bridge on the OS, on the host that's running this. I can go through and just close this down at the moment. You see the VM is running, should be able to connect back into it. I move everything up to the top, so the Control and L. And now when we go through, and even after the reboot, you must remember that your history is maintained. It's actually written through to a file in the user's home directory. So even though we had rebooted, I can still recall my previous history, and we can see now that that file does exist. So I have got my KVM support on the virtual machine. So now I could go through and run the install, or if I wanted to, I could go through and install OpenStack. But we've seen that we can get the items all up and running the way that we want. Now, I don't have a lot of resource here. Remember, it's just a 40 gig disk, and I set this up with 4 gig of memory. If I go free and then -m, it will show it in megabytes. So we can see the total amount of memory and how much memory I've got free. So it's not going to be available to run huge amounts of virtual machines, but obviously I could assign more RAM, and I can do that whilst the machine's up and running if I wanted, but it's just a proof of concept here. So I jump back now into the slides and just see what we need to get up and running. To install, we need to update our metadata about the repository. So we should start with a sudo and apt update. And then we can see the packages that we need to add. So we've got the apt install, and then we've got QEMU, KVM, libvirt clients, the libvirt daemon systems, bridgeutils, Virt Manager. So that's the graphical tool, the virt install. So that's the command line install. The cloud image utils, remember that gave me the cloud local ds command to create the ISO file. And then if we want to set up the name resolution, then the lib NSS and libvirt. And again, we'll just prove that it all runs. So sudo apt update. So your typical Debian-based system where we're looking at updating the metadata. So this shouldn't take too long to run because it's only about what packages are available. It also shows that some of my packages can be upgraded, but I don't worry about that at the moment. And then we can go through starting the install. So apt install. I'm just going to put the -y on so it doesn't prompt me to accept. And then I can do keymoodesc kvm and get used to using tab completion. Type a little bit of it, but then use tab completion, because what I don't want is, especially early on, to be making a typo and then finding I've got a backspace through 200 characters to fix a typo early on. So we can then go through and do our libvirt and then clients, our libvirt and daemon, and that's the system. So all the time I'm using the tab completion, just hitting the tab key once I've typed a little bit of it, just to make sure that my typing is going reasonably okay. Now we're onto the cloud and then the image and utils, and then the lib, last one, lib NSS, and then libvirt. So there's a little bit to run through here now, but again, all of these are going to be retrieved from the internet-based repositories, and then the installation will go through. So we've retrieved everything, we're then bringing them down for the install, and you can see towards the bottom of the screen the progress. And as I say, this will take a little while to go through. We don't really need to wait for it to run through, but we've now taken a look at the whole process. So whilst this is cooking, if we jump back and just quickly flick through what we've looked at. So yes, we were setting it up, and we talked about the virtues of keeping our virtualization hosts separate from our desktop. So we don't have to run our virtual machines on our desktop, nor do we have to be worried about graphical environments on the server. Keep the server for server-based applications. The desktop is where our graphical tools can run. So we then went through seeing how we can create our virtual machines, either through the GUI or the CLI. We start seeing some of the real benefits of the graphical tools compared to the CLI, with all of the options that we've got to set in. Unnested virtual machines, perhaps where we want to then test our own cloud environments. Downloading cloud images, setting up our resolvable host names. So we went through a bit of the history of KVM, ways we can check for our support. The traditional ways are flagged, but really it surprises me still so many places say to check for the flags, where all we need is the /dev/kvm file. So we can go through and download our cloud images. So these are going to typically come down as the Ubuntu image having the Ubuntu user, the CentOS image having the CentOS image. But by default, you'd need to inject SSH keys to be able to authenticate. So we saw then how, rather than injecting the SSH keys, we could keep it simple and just use password-based authentication. We looked at adjusting the disk size, so using the QEMU image command, creating the disk by converting it, although we were QCOW2, this then becomes a reliable way to make sure even if it came down in a different format, it's converted to the correct format for KVM. The customization. So if we recall, the file that we create has to start with our #cloud-config. Once we've done that, we can then go through and start setting items. Here we've got some very basic things. The password, and that's the first user or the default user. Setting up the password not to expire, allowing SSH password-based authentication, and setting the host name. This is pretty much to the minimum that we want to set. Sometimes perhaps you don't want password-based authentication, so you would put a public key from your SSH client. We then use the Cloud Local DS utility to create the ISO, and the ISO then is used on that first boot. So we've seen the virt install script that we've got, but as I say, it's quite easy with the graphical virt manager. Connecting to the VM, so we can use virt console, but console's only going to work where you have set up a serial console. Typically cloud images do. But we could find out the IP address from the DHCP leases for the default network, but we could also use our name resolution. When we're looking at our nested KVM support, we can then go through and set in our graphical virt manager the copy host CPU configuration, or use virt edit in the VM name and set the host model for our CPU mode. For our host system, so we only need to do this on the physical host, make sure that we've allowed nested virtualization, so setting the option for when the module loads. And then installing it, we've seen then the packages that we've looked at during this brief webinar. So if we set this up, we'd have both QEMU and KVM virtualization, as well as the tools that we need to manage it in the way that we've seen. So we should be just about finished. So we can see all of this now has run. And if I go through and look at, let's say, version list, obviously we won't have any virtual machines at the moment, but we can see we're kind of up and running with our virtualization. And there we have it, ladies and gentlemen. We're now ready to pass back to see if you have any questions you'd like to try and quiz me with.
Sure, I have a question. Is there any performance difference between using, say, QEMU with KVM versus a platform like VMware Workstation or VirtualBox?
VirtualBox, VMware Workstation are all good utilities, but if you're not going to have those on a separate system, then again, we're tied into it being your desktop. And what I find is I don't want my virtual machines on my desktop. So although I do use VirtualBox, and VirtualBox is free, obviously there are things like VMware Player from that are available that are free as well. So we don't have to worry about paying for those, but it's just the fact that I don't really want them on my desktop. As far as performance benefit, you should find on the same hardware running the same virtual machines that the performance should be better, and there are independent tests that say if you have got your guest editions or your virtual machine tools installed, which are supposedly accelerators, the KVM acceleration is still the one to go for, because it's working at the kernel level on the system rather than at an application level.
Okay, that makes sense. I think that was the big question in here. Just got a link that I'll try to include in the notes afterwards about the pros and cons of VirtualBox versus QEMU. So following along with what you said. It's very
and if I send in the slides, they can be made available. If I send them into Tracy, will that work, do you think?
Absolutely. So we are going to post this up on YouTube as well, meaning that anybody who did not have a chance to see the whole thing, you'll be able to see it. Or you've already seen it because you saw it already on YouTube. It's the time works strange ways. So thank you so much. Thank you very much, Andrew, for coming in, giving us a great presentation on virtualization technologies on QEMU and KVM. We appreciate it.
Thank you.